Hey, how you doing? Coming from my living room. Got that coronavirus out there. Got to be safe, right? Okay, this is fun though. This has been really fun. Okay, I hope you're taking notes. This is part four of our series on interest. Okay, we started first with simple interest. Now, for the last couple of videos, we've done compound interest. Okay, there's this idea of charging interest on interest. Okay, if you need a review of that, just look at the past couple of videos I made. All right. Anyway, we started. Well, we didn't start. We started with simple interest, but then we came up with this idea of charging interest on interest. Okay, and we called it N. The number of compoundings, okay, is when the computer looks at your money and charges you interest. It could charge you every year, okay, and that's what we started off doing. But then I think it was the last video we said, well, what if it were every month that they charged you interest? Okay, it was a smaller portion of the interest, but still charging you interest on that interest and then just keep on adding it. Okay, it amounts to more over time. So we came up with our newest formula. Okay, once again, accumulated wealth, amount, whatever, principal, the money you start with, one. Okay, you got to have the one in there. Okay, otherwise you're just taking a percent of, you're taking the rate of a principal, but you want to add the principal to it because you want the total. Now the R, we said it was be 12%. The N, we said in the beginning it was 1 year. So this was one and this was one. You note if this is one and this is one, you just got P times the quantity 1 plus R to the T. But when we introduce compound interest, that changes our formula. Okay. All right. So last time we said, oh gosh, what if we wanted money for a motorcycle that costs $500? You're borrowing, you go to a bank and they say, oh, 12% interest. And we said, well gosh, what if we charged every month this interest on interest? Okay, and we got $715, something like that. But now, today, I want to say, what if that's every day? 365 days in a year, right? 365 over here for 3 years. Look at this. Okay, so we divide 0.12 by 365, add 1 to it. I always forget to add 1 to it. Okay, and then we raise that to this big power. So all this becomes 1.433 and some change. Okay? I'm multiplying that, kept it all in my calculator. Okay? I'm multiplying that by 500 times 500. Okay, so we get $716.62. All right, now, what if, this idea is only a few hundred years old, what if this number just kept on getting bigger and bigger? Instead of every day, the computer was looking at your money every hour, every minute, every second. Well, there's something called continuous compounding. Okay? Now, mathematicians, one by the name of Euler, okay, said okay, what if this number just got huge? All right. So he kept on putting bigger and bigger numbers, but it kind of topped off at 2.71. Okay. This whole designation here, this whole quantity became 2.71. It's called Euler's number. It's on your calculator. It's really cool. It's an irrational number, kind of like pi. It's kind of like the pi of the investment business, okay? 2.71, real close, all right? Doesn't get much bigger than that. So we just use 2.71, and then it goes on and on and on. Never, it's a never-ending decimal. It's non-terminating and non-repeating, so it's irrational. Okay, let's use a different formula. Let's replace all this gobbledygook with E. A equals P, that's our principal. E now, E is replacing this to the RT. Okay, now notice this is R and not N. Okay, because that compounding is in the 2.71. Okay, so we don't have to worry about that. All right, let's see what we get. A, 500. E, now R is still 0.12, half the interest for 3 years. All right, I go to my calculator. I find E. Okay, I found E, and I'm raising that to the 0.12 times 3. Okay, all right, I get a long decimal. Okay, 1.4333. Okay, times 500. All right, guess what? You should get $716.66. Not much more, right? Okay, 4 cents. But we're talking big money. We're talking huge corporations doing business. They're talking millions of dollars. Okay, billions. This could mean the difference of thousands of dollars. Okay, and it does. There's transactions taking place every day. And what am I saying? You've got scientists that are measuring the growth of a bacteria population. Okay, there's scientists working on this coronavirus. They've got that little critter in a petri dish, watching how it multiplies. Okay. In fact, let's try one. Let's try. Erase all this. Here's our new formula for continuous